Hey guys, welcome back to another episode of the Mind Muscle Connection podcast. Today I have a very special guest back on for the second time, Dr. Stephan Guyenet. If you aren't familiar with him, he is the author of the book The Hungry Brain. He has his Bachelor's of Science in Biochemistry at the University of Virginia and completed a PhD in neuroscience at University of Washington, and then went on to study the neuroscience of obesity and eating behavior as a postdoctoral fellow. So Dr. Stephan Guyenet, welcome back on, and really appreciate you taking the time out to come on here, not only for the first time, but the second time as well, too. So looking forward to catching up with you.
Yeah, my pleasure. Thanks for having me on again.
Did I pass the name test?
You did. You pronounced it perfectly. Thank you.
We were off air, we were going over it, and I had it right the first time, and then we started saying the wrong way to say it. And I told him once I hit record, I was hoping I didn't fall back to the wrong way. But cool. Yeah. So last time we had you on was, I believe, so I'm in episode, this is going to be episode like in the 400s. I think it was episode like 170, somewhere around there, but it was back in April of 2022. So currently we're in July of 2024, almost 2.5 years. So has there been anything that's gone on with you in the last 2.5 years? Anything that's like different, or any updates or anything like that on your end?
Yeah, there have been several things. Science doesn't stop. There are several areas where our knowledge has expanded, and in some ways, it has further supported things that I said in the book, and in other ways, it's undermined certain things I said in the book. So I'll start with the first one, what has been undermined. I think one thing I have less confidence about than I used to, or I should say one thing I have low confidence in now that I had higher confidence in before, is the idea that our total energy expenditure, so our body's total energy requirement, is strongly affected by physical activity. So in the book, I made the assumption that our energy requirement is related to both, or let's say our energy balance is related a lot to how much we exercise as well as how much we eat. But research conducted, particularly by a researcher named Herman Poncer, as well as some other people, is suggesting that it's not such a tight relationship between the amount of physical activity we have and the amount of energy we expend. It's a pretty controversial idea. However, I've gone and reviewed the strongest evidence that I could find on this, which is randomized controlled trials where they assigned people to either do pretty substantial amounts of supervised physical activity. So they're actually verifying that people are doing the physical activity that they're assigned versus no physical activity or light physical activity. And then they follow body composition over time. And yeah, people do lose fat, and it does seem to be dose dependent. In other words, more exercise causes more fat loss, but it's not as much as you would predict. If your model is that if you do 100 calories of exercise on a treadmill, then your energy balance will be changed by 100 calories in the long run, that model is probably not correct. I'm not going to say that with 100% confidence, but I think that's probably true. And we see it in randomized exercise weight loss controlled trials. Like, exercise just does not seem to be as effective for fat loss as diet does. And not to say it's totally ineffective, it does have an effect in most people. It probably varies by person, but in most people, it does have an effect. But it's just on average not as large of an effect as diet. And especially when you factor in the kind of effort required. Because if you're really trying to lose weight with exercise, most people are gonna need a pretty high dose of exercise. And that's a lot of time and effort. And if you're somebody who wants to do that, or you're doing it anyway, then there's no problem. But if you're somebody who right now who is sedentary and not eating well and wants to lose weight, and you're trying to decide what your strategy is, it's probably not the most efficient standalone strategy. If you're somebody who wants to maximize your fat loss and throw everything at it, then yeah, you probably want to do diet and exercise. But basically yeah, what the model suggests, it's not that there's no relationship between energy expended in physical activity and energy balance. It's just that it gets partially compensated. So if you burn 100 calories in exercise, maybe 60 or 70 of those get compensated by your metabolic rate going down a bit at other times. And so I think that's a pretty significant update. I think energy balance in that way is not quite as simple as we used to assume it was. pretty much everyone, including me, used to assume, because you put someone on a treadmill, they burn a certain number of calories. Like, you don't think that they're going to compensate for that later. And it takes a long time too. This doesn't happen in one day. Because if you exercise 100 calories today, it actually will change your energy balance by 100 calories today. The compensation happens in the long run, like months to years. Your body's okay, this is our habitual energy level. We're going to make things a little more efficient to bring down that total expenditure so it's not permanently elevated. It's almost like your body doesn't really want to jack up total energy expenditure too far. And that, I think, if you're doing very high levels of physical activity, I think that starts to go out the window. I don't think the body can adapt infinitely. But for the ranges that most people are doing, I think there is pretty substantial adaptation that's happening that's limiting the energy balance effects of exercise. Now, of course, there's no question that especially strength training type exercise increases your muscle mass. Like, that's not being questioned here. It's more the question of how it affects the fat mass portion of your body composition. So that's the thing. That's the main thing that comes to mind that I would say the evidence has developed in a way where I would want to correct or soften something that I said in my book. And again, I do want to note that this hypothesis is fairly controversial. It has been criticized with some pretty compelling arguments. I don't want to say that it's like a total home run at this point, but I'm fairly convinced that there's at least something going on in that direction. So I'll just pause there. I can go on with other updates, but I'll just pause there if there's any comments or questions you wanted to make.
Yeah, so this is the concept of like energy, what is it? Exercise energy compensation, correct? That's maybe what it's been termed. So it sounds like for you, it was initially like when you wrote the book back in 2017. I'm assuming that's when it was published, but you probably were working up to that for multiple years before that, right? It sounds like when you went into it, it was the kind of thought was like basically it would be any kind of exercise you did, there was just an additive effect to the
Yeah,
energy balance, right? Whereas like now, as more research has
exactly.
come out, you're saying that essentially it may not be the case, right? There's a ceiling to it there with that. So I guess would a couple questions off that, and you hinted on this. Genetics, would that play a role? And then with the energy balance you're in, would that potentially alter it as well too?
When you say the energy balance you're in, could you be more specific about what you mean there?
Yeah, if you're saying, say you're in an energy deficit from nutrition, right? So diet, you're in that energy deficit. You try to also do a ton of cardio, right? In the fat loss example, would that be something that could alter it versus somebody who is eating more food in general? Is that something where maybe you would see a difference there with that potentially?
Yeah, yeah, yeah. That's a really good question. And say again what the first question was.
The genetic
Yeah,
side
yeah,
of
yeah.
things.
Okay. I think genetics affects everything. I don't have specific evidence to cite for this thing in particular, but almost anything that can be measured is influenced by genetics to some degree or another. And most things are influenced pretty strongly by genetics. And I would guess that genetics does matter. But again, I don't have any direct evidence to base that on. To answer your second question, yeah, I think it does actually matter where your energy balance is. So the studies that I looked at were primarily conducted in people who started off at just standard comfortable energy balance, not not weight reduced, but usual weight people. The studies I was referencing, the randomized controlled trials of exercise interventions, where people were not losing as much weight as predicted from the additive model. However, there are other studies that suggest that exercise, even though it's not that great for fat loss, it seems to be better for fat loss maintenance. So once you've lost fat, it seems to be more helpful in maintaining that loss. And actually, it seems to be one of the best tools there is for maintaining that loss, as far as I can tell. And that could be consistent with Ponser's constrained energy balance model, constrained energy expenditure model, in the sense that if you believe, or let's say if you assume that the body is regulating energy expenditure around a particular level, let's say your energy expenditure is 3,000 calories a day, your body doesn't really want you to go above, I don't know, 3,200, 3,300 or something as a result of physical activity. But let's say you've reduced your weight and now your energy expenditure is 2,700. And you can add physical activity up to 3,000 without exceeding that level that your body is regulating at. So potentially you wouldn't get the same kind of compensation, at least in theory, according to that model, if you believe that whatever that threshold is doesn't change with weight loss. So that's a lot of ifs, but I would say that it is consistent with what we see in studies of weight maintenance, where exercise seems to be particularly important there. And it was also supported by Kevin Hall's Biggest Loser study. Have you heard of that one?
I have, yep.
Yeah, just to review for the audience a little bit, Kevin Hall's group followed up with people who were winners of I think they were all winners, or I don't know if they were all winners, but people who lost a lot of weight on the show Biggest Loser, followed up with them long term to see what impact that had on their energy expenditure. And what they found is that their resting metabolic rate was very depressed. So their resting metabolic rate was very low years after they had done The Biggest Loser. And they were still weight reduced at that time. Yet they found that the people, let me see, they found that the people with the lowest resting metabolic rate actually were the ones who maintained their weight loss the best. So it's the opposite of what you'd expect. And probably the reason is that those were the people who were exercising the most. And that was probably why their resting metabolic rate was suppressed. So their total energy expenditure was probably not particularly low. It was just their resting energy expenditure that was low. Yeah, now that I spell that all out, I'm not sure that it's actually very supportive of the point I was making, but it was an interesting study anyway.
Let me ask you this. So you mentioned the resting metabolic rate there. Where like you said, it's not something where like that day you necessarily see it. It's usually like over time that you see it, right? It's like
Yeah.
months, years, stuff like that. So what is the main, at least again, like I'm sure this isn't set in stone. Like I'm sure there needs to be more research on this, but where are we speculating that this energy is coming from? Is it resting metabolic rate, or is it, yeah, where do you typically see that from?
Yeah, I honestly haven't been following that research in enough detail to know if they have figured that out. In the Biggest Loser study, there was a reduction in resting metabolic rate. So it seems like a good candidate, but I don't know if there's other evidence on that now.
Yeah. With this kind of change and some of the research there with that, how would you change your recommendations here on this in the book? Is there anything specific that you would have somebody do differently now with this, or yeah, what does that kind of look like?
I think the main thing that I would want to change is that in one of the early chapters of my book, I really make an argument for the additive model of energy expenditure. I'm implicitly assuming that's true, and that physical activity, reductions in physical activity over long periods of time, like over the last century, were a major contributor to the fact that we've gotten fatter. And I think I would just provide more nuance there and soften it and say reduced physical activity could be one contributor, but it might not be as big of a factor as we used to think, at least not through its ability to increase total energy expenditure by large amounts. And I just wouldn't assume that the additive model is correct. I would put in a little bit more nuance there instead of just saying you exercise 200 calories on the farm and that increases your total energy expenditure by 200 calories. And if you're not eating 200 calories more, you're going to be leaner. That said, I do want to add that when we're talking about life 100 years ago, many people were extremely physically active, like people working on farms, people working in factories, heavy manual labor jobs. Like most people had manual labor jobs. At least most men had pretty heavy manual labor jobs. And women were more physically active too. Like they didn't have washing machines back then. So what do? You get your washboard out and you're scrubbing clothes like every day. So people were, I think, many people were actually very physically active. So even if there is a constrained impact of that on energy expenditure, it probably, once you get up to that level of physical activity, it probably is having some kind of significant impact.
Yeah, because this is the main thing I hear when people talk about like Herman Ponzer and his research. It's they take it the wrong way and take it like, oh, so you're saying that like exercise, like you shouldn't do it. It's not important. No, it's still like super important, right? And so this kind of leads to my next question on this. So we know that again, there's probably this constrained energy. You're not just going to be able to continue to move more and you're going to burn more calories, right? So again, some people would take that as, oh, so I don't need exercise. No, you still need to. What I'm assuming there's probably going to be some benefits outside of energy expenditure from a physical activity standpoint, exercise, right? So like you mentioned, when the research shows that like weight maintenance, it's great for that, which is super important because that's an issue for a lot of people. But again, you're the author of the Hungry Brain. So how does like physical activity, how can it impact your maybe ability to like moderate your food intake, or does it?
Yeah, there is some evidence in rodent studies and human studies suggesting that physical activity, actually, I'm going to put it differently, suggesting that physical inactivity dysregulates appetite. It dysregulates your brain's ability to maintain energy balance. And a lot of people, not everyone, but a lot of people in our society are very physically inactive. And if you do this in rodents, what you'll see is that if you have rodents, if you give them graded levels of physical activity, so either no physical activity, a little bit, medium, a lot, you'll see that the amount of food that they eat starts off elevated at no physical activity. It actually goes down a bit with low levels of physical activity. And then as physical activity goes higher, then it goes higher again. And so basically, most of the physical activity range in that experiment, you're getting a good match between energy needs and energy intake. That physiology is maintaining energy balance effectively. But on the very low end, it's not maintaining energy balance effectively. They're over consuming relative to their needs. And you see something similar in some human studies. And they're not like the most amazing studies, they're observational studies and people with different levels of exercise, but they are consistent with the hypothesis. They find basically the same thing that you find in the rodent studies, that there's a bigger mismatch between energy needs and energy intake at low levels of physical activity. So it's not necessarily the case that you need to exercise a lot to get that effect, at least from the evidence that we have now, but you don't want to be inactive. And I think that's what like all the evidence says. Like you don't want to be physically inactive. And I will say, I absolutely believe in the health benefits of exercise. And it's not just about health, it's about quality of life. Like, how well can you move? How well can you do the things you want to do in your life? And how well are you going to be able to do those things when you're 70 or 80? That especially when people get older, that's when you see huge divergence in how people's lives are based on how well they've maintained their physical activity level. And to me, that's just like such common sense that you can't even dispute it. In terms of the health outcomes, I believe that physical activity is important. I will say that I think that a lot of people are not sufficiently skeptical about some of the evidence that we have about the link between physical activity and health outcomes, like mortality risk and risk of heart attacks, diabetes, etc., because most of that evidence comes from observational studies, and it's just really hard to eliminate confounding in those studies. People who are highly physically active probably have a lot of things going for them. They are physically already healthy enough to be able to exercise. So they probably, at baseline, don't have any kind of chronic diseases. They feel good enough to exercise. Their physiology, their neurobiology is operating well enough. They're motivated enough to exercise, and having higher levels of drive in your life, that is probably going to produce better outcomes across a range of things. They probably have higher health consciousness than people who don't exercise. So I don't think it's possible to eliminate confounding in studies like that. You can adjust for a few things like how people eat and how much medical care they get, do they smoke, whatever, but I don't think you can adjust away all those confounding factors. So when I see these studies that suggest that people who exercise have like way lower mortality rates than people who don't exercise, I'm like, okay, I believe it's beneficial, but do I believe that the effect size is that large? Probably not. So yeah, that's my high level perspective on that body of evidence.
Can you maybe, because again, I don't think you said there's a ton of research on it, but can you maybe speculate like why? Again, maybe you said again like there's a lot of these kind of other variables at play here, but like somebody that is, and I guess my question is, can you speculate on why you think that somebody who is physically inactive, like why their appetite is dysregulated?
Yeah, the only thing I will say, so I don't know what the specific mechanism is, so I can only speculate. I'm not aware that anyone knows. Maybe somebody knows, but I haven't heard about it. What I will say is that we evolved as physically active creatures. That's the context in which our physiology evolved. And if you take your physiology far outside of the context that it's accustomed to, stuff's not going to work. And so that's not a very specific argument, but I think that's, in my view, that's the general idea.
Yeah, no, I mean that makes sense, right? It's like it's not what we're used to, and so again, you're gonna when you're not doing things that you're not used to, it's you don't know what's gonna happen there with that. I always wonder too, and again, this doesn't have anything to do with the brain, but I always wonder too, like in those, is it partly like just bored, like you're just bored, so you want to eat more? But again, that wouldn't tell us like why the appetite is dysregulated there.
Yeah. That's an interesting hypothesis, though. It could be right. And it could apply to rodents too. They really like running in wheels. So if you take away that entertainment or activity, expression of energy, maybe they put some of it in food. Maybe humans do that too. Yeah.
Yeah. Again, like you said, we don't really know for sure there. So really all is speculative. Real quick on this, last thing here on this, I think this kind of concept of energy, exercise energy compensation, I think a extreme example of this would be like, because a client asked me this a while back and I was just, and this was years ago and it makes more sense now. And I think this goes to show, and I think this is what you're saying is at the end of the day, the diet side of things is super important in terms of dropping weight, managing weight and everything like that. He brought up post office workers, right? People, mailmen, mail women, people, and you always talk about activity, and but sometimes you see these people that they get probably 20, 30,000 steps a day and they're still overweight, right? At least some people, can you explain that? And at first I was like, but it makes sense, right? I think that they're probably, their hunger increases. They, again, they don't burn as many calories as you would think because their body's kind of adapted to that over time. And again, there's that mismatch there of the energy and they probably just are that's out of whack there.
Yeah. And also, I would say, what would they look like if they weren't doing that exercise? They probably would be fatter to some extent.
Yeah, yeah.
Yeah.
So it comes back to again the nutrition side. You don't know what like you don't know where they would be at if they weren't getting all that activity
Yeah,
either. So
exactly. What's the counterfactual? And you don't know what their genetics are either. Like some of those people could be highly susceptible to obesity, and that exercise is actually helping them.
manage it.
Mhm.
Cool. Is there anything else you want to add to this kind of concept before we move on to anything else that you want to add to your book? Cool. Yeah. So I'll hand it over to you again. Is there another thing that you over the last few years research that's come out that's really kind of something that you, man, I really want to add this to the book at some point?
Yeah, the two other things that come to mind that it's been really awesome to watch in the scientific literature, and these are areas where the research has continued to support what's in my book, is the genetic research, genetics of obesity and body fatness, and the pharmacology of treating obesity. So the new drugs that have come out, that's been incredible. So I'll start with the genetics. I talk about the genetics of body fatness in my book, and I still agree with the things that I wrote there. But if I were to write it again, it would be a much longer section and I would go in much greater depth. Yeah, twin studies where, yeah, I won't go into detail on the methods, but it's a way of estimating how much of a trait is due to genetics versus factors other than genetics. So genes versus environment. They suggest that about 75% of differences in body fatness between people in a country like the United States are due to genetics. And there's debates about this. People debate what's the best way to measure it. Some people would say that's overestimated, but I don't think there's a I don't think the number is plausibly below 40%. So depending on the study design, it can be anywhere from 40 to 80%. And I think the stronger study designs tend to be on the upper end of that range. So I feel pretty comfortable saying that at least half of differences in body fatness between people is genetic. So this is a huge determinant of body fatness. And I think this makes total sense. I think a lot of us intuitively resist the idea that genetics is important because I don't know, we don't like to think that we're being controlled by things that are outside of our control, but we know that there are some people who struggle with body fatness and some people who don't. And you can't explain that fully by how they're eating and how they're living or the choices they're making. Like some people just have a bigger appetite. Some people eat well and they still put on fat. Some people exercise a lot and they put on fat. And then you have siblings that grew up in the same household and one of them has obesity and one of them doesn't. So you can't pin it all down to environment or choices that people are making, although that also matters. So that's part of it. And then the research that's been really amazing has been the research on where they're looking at the specific genes that are driving these genetic differences. And they're saying, what do these genes do? And overwhelmingly, what the research has, from beginning to now, has suggested is that these genes are primarily involved in how the nervous system is built during development and operates after development. So almost all of the gene, I shouldn't say almost all, but the by far the large majority of the genes that affect people's body fatness are genes that relate to your brain. And a lot of these genes, we don't even know what it is about them that's modifying body fatness because there's like over 1,000 genetic locations now that have been identified. And these are genes that do all sorts of things like neurotransmitters that are everywhere in the brain, affects how it gets released or how synapses get formed in particular part of the brain. We're just like, we don't, most of it, we don't even know how it affects body fatness. We just know it's something that's happening in the brain. These genes are not affecting the liver, they're not affecting the pancreas, they're not affecting what your taste buds, like it's your brain. And predominantly, not to say that's the only thing, but that's by far the biggest signal. And so that really goes to show that it really reinforces this idea of the brain being central to body fatness. And this is one of the things that I really object to with people who are arguing that it's not about the brain, like the carbohydrate insulin model people who want to say it's about the pancreas or fat cells. I'm like, if it's all about the pancreas or fat cells or all about insulin signaling, why are insulin signaling related genes not the ones that are showing up as the ones that determine body fatness in free living population, in all of us, in regular people living their regular lives? Like those are the people who are getting fat. Why are these associations not showing up when we look at the genetics? If you look at these studies, I'm talking about genome-wide association studies. They're really good at accurately identifying biological mechanisms. So if you look in other contexts, if you look at the genes that cause people to be taller or shorter, they're genes related to bone development, connective tissue development, growth hormones. If you look at genes related to diabetes risk, they're genes related to beta cells, insulin releasing cells in the pancreas, related to insulin sensitivity, related to body weight. If you look at genes related to allergy risk or autoimmune disease risk, they're immune system related genes. If you look at genes related to psychiatric disease, they're brain related genes. So these studies they're very unbiased, they're very rigorous, and they're very good at accurately identifying the biological mechanisms that are underlying a particular condition or trait. And so to me, if this type of study conflicts with your hypothesis, it's time to get a new hypothesis because that's like the best evidence we have. And so that's something that I object to is people who don't take those findings seriously enough. And yeah, that to me has further strongly supported the central role of the brain in body weight regulation. And the specific brain functions that I've emphasized in my book, like you could debate whether those are the most important ones. You could debate whether maybe I should have added something else or subtracted something or emphasized or de-emphasized. But the big picture that the brain is central is just, in my opinion, pretty rock solid at this point. Yeah, so that's one thing that's been really cool to see. And there are also lots of studies that are just like really fine mapping the neuronal populations. So just to make sure everybody in your audience knows, neurons, brain cells, So fine mapping, and there's like a million different kinds of neurons that do different things. They express different chemicals. They're hooked up in different ways. They regulate different things. And so researchers are really fine mapping which ones are doing what related to eating behavior and body fat regulation in the brain. And it's just been really cool to see the level of detail deep in that research. And then actually I'll pause there. I'm going to talk about the drugs next, but just wanted to pause in case you had any reflections or questions.
Yeah. So again, just to make sure I'm on the same page here as you. So it sounds like in the book, it was like, again, from a genetic standpoint, in terms of the brain, it was like maybe you thought initially it played less of a role. Obviously, we know the brain plays a huge role, but now you're saying you think there's a little bit more genetic aspect to it than you initially thought when you wrote the book.
No, it's my thoughts on it haven't changed since writing the book. It's just that the research has strengthened the
That's
same
right.
conclusion that I already came to and just really fleshed it out.
Okay, so that's right. Sorry, the first one was the one you wanted to change. This is the one that's really strengthened what you thought
Yeah.
there with that. So what can somebody like do with that? What? Okay, so we know that hey, there is a huge genetic component to it. So does that mean that for some people it's just they're screwed, or is it more they're just going to have to work at it a little bit harder than somebody else, or they're just going to have a little bit more challenges than somebody else may have potentially?
Yeah, mostly the latter. Like I hate to put it this way, but I do think there are a small number of people who are just screwed, as you put it. If you have a rare mutation that really messes your energy balance up, like leptin deficiency, for example, or leptin receptor deficiency, those are mutations that were originally developed in mice and spontaneously. And the way, like leptin receptor mouse, the OBOB mouse that I talk about in my book, initially they thought it was pregnant until they realized it was a male mouse and it was just enormous. And those mice are just like many times fatter than a normal mouse and insatiable in terms of their appetite. And there are humans that were identified not long after they identified the leptin gene from these mice. They identified humans that were missing leptin and then later the leptin receptor. And it does the same thing to humans. They have extreme intractable obesity and they are insatiable, extremely food motivated to the point where it's extremely pathological, like digging for food out of the garbage, eating frozen food straight out of the freezer. You can't put them on a diet. Like it just is not practical. You would have to lock them in a jail cell. If you're that kind of person, yeah, that's going to be rough. Like you're not ever going to have a six pack. And except I will say that leptin deficiency, so missing the leptin gene, that is now treatable because you can just inject people with leptin. If you're missing the leptin receptor, you're out of luck because you can't, that doesn't help. Those types of mutations are rare. Those types of mutations are quite rare. There are more common mutations that are not that rare that occur in melanocortin receptors and melanocortin related genes. And those are part of the leptin signaling pathway. And those will also create, and it's not as extreme as leptin deficiency, but it will creates obesity that's very pronounced and hard to treat. And that's in a few percent of people with childhood onset obesity. So we're talking about the more extreme cases, not super uncommon, but definitely not super common either. And there are actually dogs that have this mutation too. I think it's actually been selected for in certain dog breeds because they're hungry all the time, so they're highly trainable. So
Okay.
some like labs, for example, they're just have bottomless appetites, but they're highly trainable because they're so food motivated.
Yeah, that's funny. You bring. Sorry, go ahead. Keep going.
No, that's it. You
Oh, okay.
can
Sorry,
comment.
I thought you were gonna maybe say something else there. I tend to be very quick to my responses here, but that's funny you say that about the dogs because I feel like that's my dog, right? He's like you said, very just bottomless pit, but like you said, the plus side is they're trainable because they're very food motivated and you can get them to do really anything there. So I guess how would somebody like No, because again, I think, like you said, there's a subset of the population that's going to be like, oh, we want to feel like we're in control of these things, so they don't think that's great. But then I feel like there's also going to be that subset of the population that's, oh, see, it's my genetics, that's what it is. So like, how would you? Is that just something that's going to be a trial and error like type thing, and you're just going to have to figure out, or
Yeah, it's not black and white. It's not black and white. There's a spectrum of how difficult it is for people to control their weight. And on one extreme are the people that I was just talking about, where it would be very hard in the modern society, almost no matter what they do, to con excuse me, to constrain their body fatness. And then on the other end, there are people who can't gain body fat no matter what. And that it goes all the way to pathological on that end. So there's lipodystrophy where people like physically actually can't gain fat at all. And that's actually a problem too. They get diabetes. So it's an entire spectrum, but I would say most people, I guess the best way I can put it is that unless you're really at the extremes, which is a small percentage of people, the environment that you create for yourself through your diet and your food environment and your physical activity and everything else does have a substantial impact on your body fatness. Yeah.
and and I'm sure it's like one of those things too, where ultimately it comes down to like your choice in terms of like how far do you want to push things, how far into it do you want to go, right? If you're somebody that maybe does struggle a little bit more, you're a little bit more, maybe your TDEE is a little bit lower, you have something like you, it's ultimately down to you in terms of how far you want to push that and what kind of method you want to, what habits you want to adopt and what you want to do. And again, you ultimately have that choice there. But I'm assuming probably, again, good evidence-based kind of fat loss practices are obviously things that we want to adopt first. And again, the get consistent with it. And that's going to be your main thing. And then from there, it ultimately comes down to if you want to, how far you want to push it from that standpoint.
Yeah. And I would say another thing I would cite is the population distribution of body fatness that we have right now, which is tends to be more shifted toward obesity. Those same genetics 100 years ago were a lot leaner, right? So it's not the genetics, it's the environment that caused that shift. And some of it might be, you could argue some of it's intergenerational. Some people might argue some of it is not from diet and lifestyle, but from like chemical contaminants or something. I'm not sure I buy that, but that is an argument. So it's not necessarily all under one individual's personal control, but it does illustrate that it's not just genetics, environment makes a big difference
Yeah.
across the weight distribution. So those people today who have the melanocortin mutation and have extreme obesity, maybe they would have had mild obesity 100 years ago.
Yeah, so it's just like you said, everything's just shifted over to more the again, same thing with the male person that we talked about. Again, there just you don't know where it could be if think like again, I think what I'm saying makes sense, and I understand what you're saying there. It's just easier. The environment makes it just way easier to have that kind of mismatch there of the energy balance with that. Cool. I don't think I have any other questions on that. Is there anything else you want to add on the genetic side of things there with that? Cool. And then I know the third one, and this I'm sure goes hand in hand with the genetic side of things as well too. But I know you said the third one you want to talk about was, I believe, the pharmacology of this as well too.
Yeah, exactly. So in my book, I guess this is one thing I would want to update in my book too, now that I think about it. I was pretty bearish about the promise of drugs for treating obesity. And mostly the reason I thought that was that historically there have been many weight loss drugs and none of them have been very good, but before recent times. And part of that is because they didn't cause as much weight loss as we wanted. And part of it was because they had side effects we don't want. And, the brain is just an incredibly complicated place and there's redundancy everywhere. Like the same signaling pathways get used in 10 different ways in different parts of the brain. And so like, how do drugs like just bathing the entire brain in some molecule, like how do you get specific enough to cause weight loss without screwing a bunch of other things up? And so that's why I was pretty pessimistic in my book. I was like, science is going to advance. We'll see what happens. Researchers are clever, but I don't feel very optimistic about this. And then 2 years later, we get semaglutide. And so that was definitely an update. But so yeah, I would definitely write that differently. And I think I'd probably have a whole chapter on drugs. I actually considered having a whole chapter on drugs in my book. I mentioned a little bit about a couple of the drugs. I mentioned the effects of marijuana. I mentioned the effects of theobromine in chocolate, which is a habit forming substance like caffeine. But like that's a rich topic. You could talk a lot about the effect of drugs on body fatness. and how it impacts body fatness. And as it turns out, most of the drugs that do impact body fatness do so via the brain. And so this is where the pharmacology really supports the main thesis of the book. If you look at psychiatric drugs, many of them cause changes in weight, often weight gain, sometimes weight loss. And many of the obesity drugs that we had prior to the new GLP-1 receptor agonists were repurposed psychiatric drugs. So a lot of these were drugs that were being used in psychiatry, and they said, hey, I noticed my patients are losing weight. Let's put these through some clinical trials for obesity. And then so they used those drugs and combined them together, lower doses of two drugs to try to get a better effect. And that was the state of things. Most FDA approved drugs before the GLP-1s were brain acting drugs that were repurposed psychiatric drugs. The main exception that comes to mind was orlistat, which inhibits fat absorption in the gut. So it just doesn't let you absorb calories. But most of the drugs were appetite control via the brain type of drugs. And then we get semaglutide, which first of all just has a much larger effect size on body fatness relative to the earlier drugs. So typical weight loss would be in the kind of 15 to 18% range in randomized controlled trials. And that's actually a little bit of an underestimate of what you would get in a typical patient in a clinical context, because that includes people who dropped out in the trials, and that includes people who didn't get very much weight loss and would discontinue in a clinical context, because there is like 5 to 10% of people don't lose much weight on these drugs, so they just wouldn't continue on that. But the people that it does work for, which is 90% of people, would typically experience 18-20% weight loss on semaglutide. And when you compare that to typical weight loss for behavioral weight loss interventions, which would be like diet and lifestyle, that's going to be, for a solid program, you're going to be looking at 5 to 7% weight loss at about a year. And typically people, after 6 months to a year, they start to regain. So that's 5 to 7% would be like before they start regaining. And most people will regain most of that. Whereas with these drugs like semaglutide, you lose 18 to 20%. And as far as we can tell, you just plateau at that lower weight as long as you stay on the drug. So you have to stay on the drug. And that's been a big critique actually of these drugs, is that you have to stay on it. But I'm like, it's not like you take statins one time and then your cholesterol is low forever. It's not like you eat a healthy meal once and then your body weight is lower forever. Like many interventions, whether it's drugs or lifestyle, you have to maintain if you want to maintain the effects. Like that to me is not surprising. So it's the same with these drugs. If you discontinue, typically your appetite and your weight will go back up. But yeah, so the one thing that's remarkable about them is the effectiveness. Another thing is that they act in the brain. So researchers have used rodent models to dissect what the neuronal populations are that are mediating this effect. And what they find is that the neurons that are receiving, the neurons that this drug is sticking to are in the brain, and they are in the brain stem specifically, and appetite regulating parts of the brain stem. So as I talk about in my book, the brain stem is the main regulator of satiety or fullness at a meal. So these drugs, they're designed to mimic gut hormones that your body secretes when you eat food. And they're satiety hormones. So they're hormones that help signal fullness. And they're also used locally in the brain to signal between neurons in satiety neurons. And these drugs go up into the brainstem and they turn on your satiety, basically. They turn on your fullness. And also, and that's borne out in trials, if you give people test meals, they'll eat like 25% less when they're on these drugs than they did before. And it's also, if you survey those people about how they feel about food, what their eating behavior is, you find that they're not as hungry, they're not thinking about food as much, they're not craving food as much. So it really seems to hit food reward as well. It's hitting the energy drive, and it's hitting the food reward and craving side. And I think that's consistent with what I've written before. I don't think I mentioned this in my book, but I've said it on Twitter a few times. The drugs that seem to be really effective for obesity are drugs that target both energy homeostasis, so your body, how your body regulates your body's energy status and energy intake, like your appetite, and the food reward side of it. So how your body is regulating your cravings and you're wanting the pleasure and satisfaction of food and specific types of food, as opposed to just being hungry for anything. And so those are really like the two big prongs that drugs seem to hit in the brain that are effective. And semaglutide hits both of those really hard. And so it really supports, I think, a few different things in the book. One, that the brain is central, because show me a drug that works on a different mechanism that is as effective as this. So it really shows that the brain is central to weight regulation again, but also it highlights two of the things that I highlighted in my book, which are energy homeostasis and food reward processes in the brain. And then semaglutide is just one example. So now there are a bunch of other drugs that are either approved or in development. There's tirzepatide, which is even more effective. That one is based on not just one satiety hormone, GLP-1, which is what semaglutide is based on, but that one's based on GLP-1 and GIP, which is another satiety hormone produced by the gut. So this gut to brain signaling pathway has been extremely fruitful in terms of developing effective weight loss drugs. And it's not really surprising if you think about it, like gut to brain, that information highway is extremely important for regulating your appetite, and appetite is extremely important for your body fatness. And then there are other drugs now that instead of just hitting two of these hormones, they're hitting three of these hormones. Those are in the pipeline right now. And by tweaking a couple amino acids here and there, or adding a side chain of lipid side chain or something, you can affect the half-life of these drugs and affect how much weight loss they cause. Even though they're hitting the same receptor, they're hitting it stronger or in a different way. And in the drug development world, they're just like doing tons and tons of different tweaks to see empirically how is that affecting the outcomes. So I would, if I were to write the book again, I would discuss drugs a lot more, because I think that is really, it really bolsters the central arguments in the book. And it also is just like a cool win for the field, because you can have all the hypotheses in the world, but until you come out with an intervention that actually works in the real world, maybe it's all hot air.
Yeah, no, I agree. I definitely think that, like you said, this medication and how effective it's been really does solidify your points with how important the brain is, right, in all this. Because I think a lot of people in the fitness and nutrition space do think like, oh, you just need to eat less and move more. And I think this goes to show, if you haven't been in that position where you are overweight, like you don't really know what's going on there. And the main kind of thing for me has been like just how important the brain is in terms of, like you said, the satiety aspect of it, and how maybe dysregulated that can get when you are overweight. And this kind of goes back to what you and I talked about initially, where we said when you put your body in a place where it's not used to, things go haywire. And I'm assuming this is one of those things there where, again, the kind of how it can just really impact your appetite, satiety there. And so this has been a nice way to be able to bring down that energy inside of the equation there.
I agree with that. And the thesis of my book that I'll just state here, because I think it's relevant here, is that we have these non-conscious brain regions that impact our eating behavior and our energy balance regulation. And those are the things that are pushing us to be too fat and the fatter than we want to be in the modern world. And I think then I'd like to emphasize the non-conscious part of that, or minimally conscious. Like these are things that are whirring around, away in the background. There's part of your brain that regulates your body temperature. You have no control over that. There's part of your brain that regulates your heart rate. You have no control over that. And similarly, the parts of your brain that regulate your appetite, your craving, your body fatness, you don't have much control over that. You may have control ultimately over your behaviors, but your drives, your motivations, which have a major impact on your behavior and your ability to sustain behavior change long term, those things are coming from non-conscious brain regions. You're not choosing to turn your appetite on. You're not choosing to have a craving. Those are just things that appear, and then you have to decide what to do with it. And we're not iron-willed creatures all the time. We're humans. These systems are survival systems. They're not designed to be overridden every day for long periods of time. And it is difficult to do so using sheer will. There are some people who are just like superhuman and they manage to do it, but the majority of people, it's just not realistic. And yeah, so one of the things that one of the pieces of unexpected feedback that I got from my book that was really heartening for me was people saying what a relief it was to learn that it wasn't just the fault of bad decision
Yeah.
making or insufficient willpower, that there were these systems they didn't have control over that were really pushing them to overconsume and to be fatter than they want to be. And so it made them feel like they didn't have to feel as guilty or as ashamed about their their drives and their behaviors and their weight. That was one of the things that I really enjoyed hearing back about the book.
Yeah, no, I think that's super important because, like you said, I think a lot of times in the fitness, I think I said this, but in the fitness and nutrition space, and again, like the kind of body composition space, it's like, oh, it's the willpower. But again, it's not all that. It is your choice, but there are things at play that you don't really have control over that do make it easier or more challenging for people. And I agree, your book was super helpful for me in terms of my practice with my clients as well too, because I think while again, it's the awareness aspect of it is super key because I think again, like you said, we don't want to not we want you to still take responsibility, but you're like you said, the fact that you know that these things are going on, you at least have that awareness going into it, and you can make, I think, more informed decisions knowing that this is going on versus like you said, oh, it's just me, it's my, and then that leads to other trickle down impacts later on. So I think that's been super helpful, and I agree. I think that the awareness is key, but then from there, you do need to, like you said, practice these behaviors, which you give in your book too, right? You also give practical applications to work with your brain versus just being like, all right, we know this is a problem. What do we actually do with it? Which I think is super important too.
Yeah, one of the things I'll just briefly add that Ezra Klein and I discussed when I did a podcast with him, he was talking about how he has a friend where if they're sitting in front of a bowl of chips on the table, his friend will be having a conversation and not even thinking about the chips. Whereas for him, he's like obsessing about it and having to stop himself
Yep.
from just eating them all. And I think that goes to show how people vary a lot in how these non-conscious brain regions operate. So some people have really strong food reward drive. So that would be more like along the lines of Ezra Klein. Some people have weaker food reward drive. Some people have higher intrinsic appetite. Some people have lower intrinsic appetite. And so you don't really know what somebody's working with. When you see somebody who has obesity, you can't really judge them because you don't know what they're working with. And a lot of those drives are strongly genetically influenced. So they may just have been dealt a difficult hand of cards in their life.
Yep. No, I couldn't agree more. Yeah, definitely see that all the time. And what I hear from clients is some people think about it more, some people don't. To be respectful of your time here, I just want to finish up with, so one, is there going to be an updated edition of the book? And then two, is there any research that you are particularly interested in or excited about or anything like that?
So I am not actively working on an update to the book. I don't have any plan for doing it. It's like maybe someday I'll get around to it, but it's a very vague idea. I may or may not. Yeah, so that's not much of an update on that, but that's what I got. As far as further research, I'm really interested in the genetics and neuroscience of obesity. I think there's some really interesting research happening on the genetics of leanness. The research has mostly focused on the genetics of obesity because obesity is the problem that we're trying to solve. But maybe you could solve that by understanding leanness, right? If we can understand people with extreme leanness, why they are that way, understand the genetics of it and the biological pathways, then maybe that's a different path toward treatment. So I'm excited about that. I'm excited to see what pharma is going to bring us in the next 10 years. And actually, a lot of what I'm excited about there is just how the costs are going to develop
Yep.
of those drugs, because right now they're super expensive. They're new, they're super expensive, they're on patent. what's going to happen when they go off patent in 10 years and there's 3 different off patent drugs? Is this going to become super affordable to where like anyone who wants to not have obesity doesn't have to have obesity anymore? That would be really transformative. And then just really ongoing deepening of the neuroscience of eating behavior and body fatness, like really fine mapping the neuronal populations, how they're interacting, how they respond to different environmental conditions, how they generate eating behavior, how they regulate energy expenditure, just deepening that whole area of research. I'm really excited about that too. And that has been happening. Like now there's been research that has been mapping the entire biological pathway from food hitting receptors in your gut to neural signals going up to your brain to dopamine being released and food reinforcement happening. In other words, food reward, wanting, creating that motivational response to certain types of food. So like it's happening. All we have to do is just watch the results roll in.
Be patient.
Yeah.
Yeah, research, man, this stuff. Yeah, definitely. As I've gotten more into it, definitely it takes time, but it's cool to see it evolve and everything like that. Stephan, really appreciate your time. Before I let you go, is there anywhere where you want to lead the audience to find out more about you or anything like that?
I'm most active on Twitter. My handle is at sguyenet. Guyenet is Guyenet. And then aside from that, I would point people to my book and Red Pen Reviews, which is the nonprofit that I run that publishes free expert reviews of popular nutrition books.
Awesome. Cool. Again, appreciate your time, and we will chat with you again in the future.
All right. Thanks for having me, Jeff.
Thanks.